Good morning, students. So I am grading your tests. I'm not getting through half of them, so if you check before class, but for sure after class, all your tests will be graded. I wanted to just let you know that the Delta Math grade that you got or looked at isn't your final grade, um, because I will look at your work and make sure to give you partial credit back. Now, with that said, if you have any questions after you see your grade on Runway, just let me know, and I'll make sure to calculate all of that. Okay, today we're actually going to be covering, we have a PowerPoint for today, and hopefully each day after today, okay? I know you guys really prefer PowerPoints, so we'll try to do it that way. Now, I will still upload the book, but just know that there's also this PowerPoint. Now, before we begin, it's actually crucial that we kind of get a sense of something. So, we're going to start doing sequences, and you just tell me what should come next. So, what comes after 4 here? Obviously, you'd be like, oh, yeah, 5. Okay, let's do some other ones. Let's do and what comes next? So this is a conjecture. You are conjecturing what should come next in this sequence. 15. So this is our conjecture. We conjecture these things. What about what would our conjecture be? 1, then negative 1, then 1, then negative 1, then 1. This would be our conjecture, okay? What would another conjecture be? That negative 1 would follow, okay? These circles are conjectures, okay? This is key for what we are going to be talking about today. Now, if you did those truth tables, here's your payoff, buddy. Granted, you should, not worry about the things with truth tables because they're useful, but they're not essential, okay? Okay, so we're going to look at the PowerPoint. So the PowerPoint is about inductive reasoning. That's 2-1, and then we'll go into deductive reasoning. So inductive reasoning first relies on us understanding what a conjecture is. A conjecture uses the observation of a pattern to create a statement using math or words or symbols, predicting what is next or what will be true. So what we conjectured the first pattern, number 1, 2, 3, 4, we conjectured 5 would go next. With 3, 6, 9, 12, we conjectured 15 was next. With 1, negative 1, 1, negative 1, 1 was our conjecture. Sure. And then we conjectured negative 1 would follow. Okay. So it's predicting what will be based on an observation of a pattern. Okay, let's make a conjecture. It's in the sequence 5, negative 10, 15, negative 20. So the conjecture is each number is a multiple of 5 with alternating signs. The next number will be 15. So we notice a pattern. Each number is a multiple of 5 with alternating signs, right? 5, negative 10. The next number will be 25. Make a conjecture about the statement. Angle ABC is a right angle. So what's our conjecture? Our conjecture is the measure of angle ABC is 9. That's our conjecture. That it is a right angle, so that its degrees match 1, match the statement below 90 degrees. Make a conjecture about the statement. Point P is the midpoint of NQ. Okay, I'm going to give you a second to think of it. Make a conjecture about the statement. Point P is the midpoint of NQ. Remember, there is a math formula that actually gives us what we mean when point P is the midpoint of NQ. Okay, take a second. Kind of got it in your head? Okay. We'll look at this real quick and then come back to it. It'll take just a second, okay? Point P is a midpoint of NQ, okay? So that would mean that point NP, this line, is going to be congruent to PQ, but also that P is collinear with so this is our conjecture. The P is collinear with NQ such that NP, the line NP is congruent to PQ. Okay, that's our conjecture. So that P is collinear with NQ such that NP, the line NP is congruent to PQ. Okay, let's make another conjecture. Make a conjecture about the statements. A certain club meets in January, March, May. So what's happening? What's between January and March is February, and what's between March and May is April. So our conjecture would be a certain club meets every other month, starting with January. So this would be January, March, May, and the next one would not be June, it would be July. Next meeting of the club, a certain club, would be on July. When you make a conclusion after examining several specific cases, you have used inductive reasoning. In fact, so this is the process of forming a conclusion based on given or observed information. However, you must be cautious with using this form of reasoning. Okay? Because if you start to notice a pattern, that doesn't imply that pattern is going to predict the future. This is so true in math, in all the modeling we have. That the pattern doesn't imply the future. But what could happen? Well, although the conjecture is based on pattern, observed is not necessarily always true. Not necessarily. What could be the problem here? Okay, let's say we have a pattern, right? We have names. What should be our people? Okay, let's say our names are Adam. So we have a guy in the class, Adam, then the girl with Abigail, and then another guy who is named Bob, a girl named Beth. Would the next person required in the class be a C? No. What if the next person in the class started with letter G? George. Well, that would break the pattern. That is what is possible with a counter example. Okay? So let's look at a conjecture. Make a conjecture about the statements. AB, line AB is converted to BC. Now remember when we did the one about midpoint? What we had to say first. We had to talk about collinear. So that this statement is not B is not a midpoint of AC. So you could make the inductive reasoning say, point B is the midpoint of AC, but what could we draw? Oh, we could draw an easy shape. So take this moment. My apologies, I'm just trying to, okay. So if I drew line AB, now this is not drawn to scale, so if you're and AC, they're not this is not on the same line. So AB could be converted to BC, but it doesn't mean that B is the midpoint, okay? If you made a conjecture, you could say that that the line AB, so you could say then, right, AB is equal to BC. And that is a true statement. Okay, so this conjecture is fine, but the other conjecture would not work. Okay, what about coldest day of the year in Chicago occurred in January 5 straight years? Is it safe to conclude that the coldest day in Chicago will always be January? The answer? Well, not necessarily, right? Could say, yeah, it's safe. 5 years in a row. That means it's going to be. Well, what about December, February? Okay. A counterexample. So our key definitions so far have been conjecture, inductive reasoning, and counterexample. Counterexample. A counterexample is one specific example that proves a statement false. One specific example is a counterexample. A counterexample can be in forms of word, a math statement, or a diagram. Okay? So counterexample is one specific. It doesn't have to be many. One specific is enough to prove inductive reasoning false. In order for something to be true, it must be true 100% of the time with inductive reasoning. In order for something to be false, it needs to only be false once. Okay, this is true with our reasoning. For it to be true, it must be true all the time. For it to be false, it only takes once. Okay, we'll come back to this and continue the presentation with the next video.